Welcome to General Physics 1. My name is Dr. Al Cordes. This video is intended to introduce you to the course and tell you a little bit about how General Physics 1 course will be run. Physics looks closely at the world around us. So we'll be studying everyday objects, and as we learn principles of physics, you'll be able to begin to predict how objects behave. Now, physics is the most basic science, and since it deals with very fundamental principles like energy, for example, it's often required for most of the other sciences if you want to seriously study those areas, and especially with engineering, which is basically an application of physics. So mathematics is the language of physics, so any serious course in physics has a substantial amount of mathematics used in it. In this particular course, there is an expectation of intermediate algebra and some trigonometry, lots of right triangle trigonometry. And however, there's no expectation of calculus. The text of the course is what's called an open educational resource. It's a textbook that was written and released free, and it's called Open. This particular one is called OpenStax Physics, and I edited it specifically for this course to cover the topics that we'll be covering. There is a free PDF of the text available right in the course, right in Moodle. However, if you would like a hard copy of the text, actually text with a soft cover, it's available at the bookstore for a very reasonable price, for about $15 or less. And you can also get this directly from Amazon. Okay, so now some of the topics that we'll be dealing with in the course. Mechanics is a big one. Mechanics deals with motion and linear motion, which is where we'll start, circular motion, rotational motion, which is an object spinning on its axis like a bicycle wheel. And we'll not only learn about motion, but the forces associated with the objects in relation to how they move, and of course gravity, and the principles of work, energy, and momentum, which are very fundamental in physics and apply to all of these types of motion. We'll look at fluids, which involves both liquids and gases, and fluid statics, which are fluids at rest, and fluid dynamics, which are fluids in motion. And then we'll move on to waves, wave motion, and then finally sound. So hopefully you'll find this an interesting course. I think you will if you give it a chance and put in some serious effort into the course. Now this is a lab course, and measurement and experimentation is an important part of science. So it's appropriate then that there would be a lab component for this course. And labs are often an interesting and fun aspect of the course. Sometimes they can be frustrating, but for the most part, if you follow instructions and do things carefully, you should be able to get a lot out of it. Now, most of the labs you'll be required to use materials from a lab kit. And the lab kit you're going to have to purchase from the bookstore, and there's information about that. Some of the labs you'll be using some software. That's free software that can be downloaded, and these labs involve video analysis. So I'll give you the videos, and I'll give you some instruction on how to use the software, and then you'll be able to analyze the videos, generate some graphs, make interpretations, and so forth. You'll need some additional materials, but this is going to be stuff that you can find locally in a dollar store or someplace like that. You'll be generating graphs, and there's some online software that you'll be getting some information about how to use it. It's very easy to use, so that's not a problem. And then after you do the lab, you're going to have to write a lab report whereby you list your results and to show your calculations and, of course, make interpretation of your results. A couple of tips about the labs. First of all, follow the instructions very closely. Also, take your time with the labs. Don't try to rush it. Be careful when you're taking notes and recording your data so that you can read it. Make sure you use the correct units. That's oftentimes a problem. And I can't emphasize this too much. Do not leave the labs until the last minute. That is just a recipe for disaster, because you have a problem with the lab, you need to ask a question, and if it's the night before the lab is due, you're just not going to have enough time. So I try to emphasize that every semester. Do not leave the labs until the last minute. Okay, some skills that you'll need in the lab. First of all, you'll need to be proficient using significant figures. Now, if you've taken a science course before, you've probably seen significant figures. If not, don't worry, we cover them the first thing in the course. And I'll be harping on this throughout the whole course, not only in your labs, but also in your homework, to make sure you use the correct number of significant figures. Scientific notation is another skill that you'll need. Hopefully you remember this from your math classes. I'll provide a link in the course for review if you would like to brush up on scientific notation. I think I said this before in the last lab. Be patient with the labs. Don't rush them. Keep careful records. And another tip is to do the lab report as soon as you finish the lab, or as soon as possible, because oftentimes if you leave it for a week or so, you forget what you did or some of the details that were important in the lab. Also, follow directions. I try to make the lab instructions as clear as possible, but sometimes things seem clear and they're not clear to somebody else. So if that happens, ask questions. Please don't ever hesitate to ask questions. I have a forum in the course that's called Ask the Professor. That's specifically for that, or you can email me, whichever you prefer. I will get back to you as soon as I see it. Usually it's within that same day. So, or the next day at the latest. So please, anything having to do with any questions that you need, whether it's having to do with the lab or anything else in the course, please don't hesitate to ask. Homeworks and quizzes. Okay, we're going to be using an online homework system that's called Expert TA. And Expert TA, you'll have to get an account. There's a charge for that. I think it's $32, $35. You can get the account at the bookstore, or you can get it directly online. It's divided up into the same modules as your course, so every module of the course will have a specific assignment on Expert TA. There will be a series of problems that you have to complete. This is going to be for your homework. Somewhere between 15 and 20, probably usually more like 20. There's a range of difficulty. They start easy and get a little bit more challenging. I pick all the questions that go in that you'll have to work out, so it's not anything that is picked by the software or somebody else. Other problems are taken directly from the text. Now, one of the nice things about Expert TA is the feature of hints and feedback. So if you're looking at a problem and you're stuck, you have no idea how to solve it, you click on the little button that says hints, and it gives you a little hint about how you might approach it. If you submit an answer and it tells you it's incorrect, it gives you feedback. Oftentimes it can figure out exactly what you did to get the wrong answer. So, for example, you may have used the wrong units, grams instead of kilograms, and that feedback will point you in that direction. Now, it's not always able to do that, but oftentimes it is. And, of course, if you get stuck with this or on any homework, I'm certainly available for questions, as I mentioned in the last slide. Homework problems are practice. You can't learn anything without practice, so it pays to spend time on it and to work through the problems till you understand it. If you work through a problem, you don't get it right, you don't understand why it's not right, email me. I'll be happy to help you. Now, there's also going to be quizzes. They're going to be timed quizzes. This says 30 minutes here, but it's more like 25. I think there's only one quiz that's 30 minutes. So, one quiz per module. It's timed. At the end of that time, you're shut off, so you have to complete it in that period of time. This is something that is going to be obviously an open book or open notes. However, you are not to use any outside sources. So, for example, if you have a question, you're not supposed to Google the question. Not that the question shouldn't be out there, because they're all my questions, but don't do that. That constitutes cheating. So you can use anything within the course. Okay, and just like the homework, it needs to be completed by the due date. Each module has a due date, and at the end of the due date, you're cut off from the quiz. You can't access it anymore. The homeworks, by the way, are a little bit more flexible in that there is a 20% penalty for every day that you submit it late, up to, I forget what it is, 3 days, 2 or 3 days. So if you're a day late and you got every homework question right, instead of getting 100 for that, you would get an 80. Another feature of the course are videos and simulations. In each one of the modules, there are 2 or 3 video lectures. So the video lectures are not meant to be totally comprehensive, but they do introduce the material for that module, go over some problems. In addition, there are PDFs of each one of the slides PowerPoint slides that are used in the video lectures, so you can download those and print them out and take notes on them if you like to do that. In addition, there are 2 or 3 simulations in each module that allow you to see some of the physics that you've been studying being applied to real-life situations. The instructions for the simulations are in PDF form also, and there are questions that you complete as you work on the simulation, and these are submitted into Moodle in a quiz format. It's not a timed thing like the actual quizzes, but it's just a method that I can use to have you submit the answers, and then I can grade them. Some of the simulations can be accessed on a tablet or a phone. Those are the ones that are written in HTML5. And there's even a PhET, that's the name of the simulations. I forget what PhET stands for. But there's an app for both Apple and Android, I believe, and you can run the simulations directly in that app. The others that are not written in HTML5, you're going to need to complete those on a laptop or a desktop, and you'll need to have Java installed on those. If you don't, most browsers already have that, but if it's not installed, it'll bring you to a link that allows you to do the installation. It's very quick and easy. So, the simulations are generally fun, and hopefully you'll enjoy them and get something out of them. Okay, some final words. First of all, check into the course often. Stay on track. Remember, online class, it's easy to put things off, and if you do that, you might find yourself in trouble. Do the reading. Remember, the reading fills in the gaps from the video lectures. Don't depend solely on the video lectures. There's going to be 2 discussion questions in every module. Make sure you participate in those. If you don't, you're going to lose credit. Do the homework and the quizzes. Get them in on time so that you're not losing credit on the homework or getting a 0 on the quizzes if you miss the deadline. Make sure you do the labs and write up the report, and don't leave those until the last minute. And then a common theme here is don't fall behind. So I hope you have fun in the course and find it challenging. Please go through all of the course documents that will have some additional information on policies of the course and things I haven't covered in this video. So, looking forward to working with you this semester.